Hey y'all, in this lesson, I'm going to teach you about the sum and difference identities for trig. I have these identities listed here, and I would highly recommend that you write these down on that sheet of paper that you might keep handy of identities or your note cards or whatever. Highlight them, just keep them right there. So you want these to be easily accessible. These are just identities that are already proven, so we can use them. The sum and difference identity for cosine is this. So if we have an angle plus or minus another angle, we have alpha and beta here, is just saying different angles, then we can convert that into cosine of the first angle times cosine of the second angle, and then flip that minus plus sine of the first angle times sine of the second angle. That flipping just means that if you start with plus, then in your formula, you're going to use minus. And if you start with minus, you're going to use plus. So we just flip that sign. Then for sine, it's a little bit different. The plus minus does not flip, but the functions do. So we do sine of the first, cosine of the second, plus or minus cosine of the first, sine of the second. And then we have two different ones for tangent here. We have the plus and the minus, and then you can see the formulas there. So just to kind of orient you to those identities, we are definitely going to be using them. So we're going to use the formulas here to find the exact value of the following angles. In the first one, we have cosine of 5 pi over 12. I don't have 5 pi over 12 on the unit circle, and it's wanting an exact value. So obviously I could type this in the calculator and I could get you an approximation of this, but it's asking for an exact. So in order to do this, I'm going to need to use my sum or difference formulas. This is cosine, so I'm going to be focusing on this formula. In order to do that, I need two angles. So that means I need to break up 5 pi over 12 into two angles that I am familiar with. So we're going to be focusing on, pi over 3, pi over 4, pi over 2, pi over 6. Those are all very familiar angles, so I can use those instead. 5 pi over 12 breaks up into, let's see, 3 pi over 12 and 2 pi over 12. We could do 4 and 1 won't work, because if I do 1 pi over 12, I don't know pi over 12, so that's not going to help. So let's reduce these and see if they reduce into angles that we are familiar with. This reduces to pi over 4, and this reduces to pi over 6. Those I do know. So I can rewrite 5 pi over 12 as cosine pi over 4 plus pi over 6. Now we'll use our formula. We have cosine of the first angle times cosine of the second angle, change it to minus, sine of the first angle, nope, sorry about that, times sine of the second angle. Now we just do some simplification here. Cosine of pi over 4, cosine of pi over 6, sine of pi over 4, sine of pi over 6. Simplify all of those as much as you can down to your final solution. Pause it, try it, come back. You should end up with root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. Simplify that, we get root 6 over 2 minus root 2 over 2. We can leave it like that, or we could simplify further and say root 6 minus root 2 all over 2. And I am so sorry, just noticed that I did not multiply my denominators. 2 times 2 is 4. 2 times 2 is 4. Very sorry. There you go. That's the right answer, not the previous one. And that's all at once. That's the exact solution with the square roots in it. The end, done. So now go ahead and try that with sine of 345. break up 345 with angles within the unit circle that we do know, then use your identity from above to break that down and simplify it further. Go ahead and try it. You might have used different angles. If you did, that's totally fine. I used 345. So then using the identities, I've got sine of 300, cosine 45, use that plus sign, then swap the angles, sine of 45, cosine 300. If you had swapped these two, that's fine. Commutative property applies, so it doesn't matter the order that you write that. Then you can figure out your angles. Sine of 300 is going to be negative root 3 over 2. Cosine 45 is root 2 over 2. Sine 45 is root 2 over 2. Cosine 300 is positive 1/2. Then we do our multiplying. We get negative root 6 over 4, not 2. And then root 2 over 4. And then we have a common denominator, so we can join those together. And that's your answer. Oh my gosh, sorry. Okay, next problem. Go ahead and try this one. Pause it, try it, come back. I went ahead and used angles 30 and 45. It breaks up into 15 and 60 also, but we don't know 15. So 30 and 45 are probably the safest bets here. And then I used the sum formula right here. So tangent of 30 plus tangent of 45 over 1 minus tangent of 30 times tangent of 45. Again, if you had switched the 40 and the 35, that's okay. You're gonna get the same answer. And then we just substitute what those values equal. Tangent of 30 is root 3 over 3. Tangent of 45 is 1. And then we have 1 minus root 3 over 3 times 1. We're going to have to do some simplifying here. Let's get a common denominator. I think that's what I'm going to do there. Multiply this. And then again, get a common denominator. On the bottom, that'd be a 3. So 3 minus root 3 over 3. Okay, right now it looks like a little bit of a mess, but it's going to clean up. I've just done some simple algebra here, so I kind of jumped through it a little bit. I traded that 1 for a 3 over 3. I traded this one for a 3 over 3. And then once you have that common denominator, you can add the numerators over the common denominator and then the numerators over the common denominator. So now I have a fraction of fractions. So I'm going to flip the second fraction, the bottom fraction, and multiply. To get, sorry, I've run out of room here, root 3 plus 3 over 3 times, flip that bottom fraction, 3 minus root 3. That purple is kind of hard to see. There's a bar right there. Still kind of hard to see. So that now the 3's divide. And we have root 3 plus 3 over 3 minus root 3. And you might think, yay, we're done, but we're not quite done. So we're going to have to do some simplifying here. We do have a square root in the denominator. So we're going to need to clean that up a little bit by rationalizing the denominator. I'm going to have to go to a separate sheet of paper since I'm kind of running out of room here. I wrote a little too big. So no worries. Going to go over here. I've got, let me go back to that. Root 3 plus 3 over 3 minus root 3. To rationalize the denominator, remember we're going to use conjugates of the denominator. So the conjugate of the denominator is 3 plus root 3. And I'm going to have to multiply that on the top and the bottom to keep it balanced. So in the top, I'm going to distribute, I've got 3 root 3 plus root 9 plus 3 times 3 plus 3 root 3 over 3 times 3, 3 times root 3, negative 3 times root 3, and negative root 9, which is 3. Oof. simplify that numerator. 9 plus 3 is 12. 3 root 3 plus 3 root 3 is 6 root 3. I'm sorry, guys. This is a mess. Over. Those go to 0. 9 minus 3 is 6. Dun, dun, dun. We did it, but not quite. We have to simplify a little bit more. The 12, 6, and 6 divide to get 2 plus square root 3. Can you believe that? All that for that nice, neat little answer. So this simplifies into 2 plus square root 3. And that is the solution. That was a lot of work for that little solution right there. But that's how you're going to do that. We have to use conjugates. Then we have to use distributive property. Then we got to simplify our square roots. So there's lots of algebra in this problem, which is why I included it in the notes, so that if you do come across something like this, now you know how to fix it. All right, moving on. We're going to go now the other way. So we are given the right side of the identity, and we're going to use that to go the other way. Because if we look at this, I don't know the cosine of 80, or the exact solution for that, or the cosine of 20 for that matter. So if we can go the other way, then maybe we can simplify this. This is a plus sign. And also, it's going to match up with, since I have 2 cosines, 2 sines, then that means that my original was a subtraction, a difference identity. So that means originally we had cosine of 80 minus 20 for it to translate to addition. And 80 minus 20 is 60. And I do know the cosine of 60. So I can definitely simplify that. The cosine of 60 is just 1/2. And that's it. Then for the one on the right, again, I don't know the sine of 25 or the cosine of 5. So I'm going to have to look at my identities to figure out which one this applies to. It's alternating sine and cosine, so that tells me that it's going to be a sine function. And the plus sign remains a plus sign from my identity. That's from up here. I have alternating sine and cosine. Plus sign is associated with plus sign. So I'm going to be adding 25 and 5 based on my identity. So I'm finding the sine of 30 is, let's see, 30's down here. We go over root 3 over 2, up 1/2. So sine of 30 is 1/2. And you might have noticed that we got the same answers here. And that these angles, you probably didn't notice this, but you might now. Those angles are complementary. They add to 90. So let's just kind of keep that in the back of our mind. I've kind of already showed you, I think in a previous video, yeah, it was a previous video, some identities where we used complementary angles. So this is just kind of an example of that. And we're going to keep that in our minds as we solve this problem down here using the sum identity for sine. So remember for that, we alternate functions. We keep the sign. So now I'm going to do sine pi over 2 cosine x. Then the only things I can simplify are cosine pi over 2. That is 0. And sine pi over 2, that is 1. Oops, I always do that. Cosine x. Sine x times 0 is just 0. And 1 times cosine x is cosine x. So we can say that sine x plus pi over 2 is the same as cosine x. And pi over 2 is 90 degrees. So I have confirmed what we found up here. All right, that's all I have for this lesson. I hope you enjoyed it. Hope you got the tools you need to solve this problem. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.